Aircraft manufacturing and aviation services play a crucial role in modern transportation. Combining advanced engineering, precision assembly, and strict safety standards, the Airbus Beluga, affectionately named after the Arctic white whale, is a vital cargo aircraft celebrating 20 years in service. Only 5 exist, yet they play a crucial role in transporting oversized parts between Airbus factories across Europe. Converted from an A300, the Beluga features a front-loading design to carry massive components like wings and fuselage sections for most Airbus aircraft, except the A380. Though not built for heavy loads, its cargo volume is among the largest in the world. With a 47-ton payload and unique missions, the Beluga remains essential to Airbus's expanding production efforts. The final assembly of the first Airbus A350 XWB began at the Final Assembly Line, FAL, in Toulouse, France, marking a major milestone in the development of this next-generation wide-body aircraft. The front fuselage section arrived at the Toulouse site on December 29, 2011, followed by the center fuselage, which was delivered by the iconic Beluga transport aircraft from Airbus in Saint-Nazaire on April 4, 2012. The next day, on April 5, 2012, Airbus officially started the final assembly of the first A350 XWB test aircraft. The A350 XWB, designed to offer greater fuel efficiency and passenger comfort, is composed of major components manufactured across various Airbus facilities in Europe. These components are then transported to Toulouse, where they are joined together in a highly coordinated assembly process. By December 2012, the assembly of the first fully configured A350 XWB aircraft had been successfully completed. This achievement demonstrated the efficiency of Airbus's global production system and marked the beginning of a new era for long-range air travel. The final assembly process combines cutting-edge technology, precise coordination, and the efforts of highly skilled teams to bring together one of the most advanced aircraft in the world. The China Airlines A350 features a stunning joint livery developed in collaboration with Airbus, highlighting a key element of the A350's design using the airline's signature colors. The elegant paint scheme blends Eastern and Western aesthetics, with a sleek carbon fiber pattern in blue and purple, symbolizing China Airlines' identity. Unlike the airline's standard livery, the traditional colored lines on the nose are removed, giving it a cleaner look. The airline's name appears under the windows near the front cabin doors, while Airbus A350 is boldly displayed mid-fuselage. The iconic red plum blossom on the tail completes the design, merging advanced technology with traditional artistry. The making of Vietnam Airlines' first Airbus A350 XWB showcases a detailed and fascinating production journey. The process begins with a delivery of major components, including the front, center, and rear fuselage sections to Airbus's final assembly line in Toulouse, France. These parts are then carefully joined together, forming the aircraft's sleek structure. Following this, the A350 undergoes precise installation of key systems and equipment, along with the fitting of its advanced wings and vertical stabilizer. Once the airframe is complete, the aircraft enters the painting hangar, where it receives the elegant Vietnam Airlines livery featuring the Golden Lotus emblem. The interior cabin is then fitted, including passenger seating, in-flight entertainment systems, and lighting. Final ground and flight tests are conducted to ensure the aircraft meets all performance and safety standards. Scheduled for delivery in mid-2015, this aircraft will make Vietnam Airlines the first Asian airline and the second worldwide to operate the A350 XWB. The airline plans to deploy the aircraft on long-haul routes, beginning with flights from Hanoi to Paris. Air India's newest addition to its fleet is the state-of-the-art Airbus A350. In 2023, the airline will induct two A350 aircraft, one A350-900 and one A350-1000, both powered by Rolls-Royce engines. Approved by India's Directorate General of Civil Aviation, this marks the beginning of a wider expansion. By March 2024, Air India expects to have 6 A350s in service. Under the ownership of the Tata Group, Air India is modernizing its fleet and operations. A major order of 470 aircraft, including 48 A350s, highlights this transformation. With advanced cabins and in-flight entertainment, the new A350s are set to play a key role in the airline's goal of enhancing passenger experience and operational efficiency. The goals: the first Airbus A350-900 for Iberia is undergoing its final assembly at the Cathay final assembly line in Toulouse, France. The process begins with the delivery of the wings manufactured in Broughton, UK by the Beluga XL aircraft. These are joined to the central fuselage, which has already been assembled at the FAL. Following structural assembly, extensive ground tests are conducted to ensure that all onboard systems function properly. Next, the pilot cockpit and passenger cabin are installed, including seats, entertainment systems, and other interior fittings. The aircraft is then painted in Iberia's corporate livery. Afterward, the powerful Rolls-Royce Trent XWB engines are mounted onto the wings. Finally, the aircraft undergoes flight testing to verify its performance and safety. Upon successful completion of all tests, the A350 is delivered to Iberia at the Airbus Delivery Center, ready to begin its commercial service. The first Airbus A350-1000 XWB for Cathay Pacific arrived in Hong Kong in June 2018, making the airline the second in the world to operate this advanced aircraft. Designed for long-haul routes, the A350-1000 offers greater passenger capacity and enhanced fuel efficiency. Compared to the A350-900, it is longer and can accommodate up to 40 more passengers, typically seating between 350 and 410 depending on configuration. Powered by Rolls-Royce Trent XWB 97 engines, it delivers improved fuel performance. The aircraft features a comfortable 333 economy class layout with 32-inch seat pitch and 18-inch width, plus a larger business class cabin. Advanced technologies such as the Airbus Force system allow real-time performance monitoring and predictive maintenance, while modern avionics support research into autonomous flight. Despite its extended size, the A350-1000 maintains 95% system commonality with the A350-900 and shares the same pilot type rating, facilitating operational flexibility. With these innovations, the A350-1000 XWB strengthens Cathay Pacific's long-haul fleet, offering passengers an efficient and comfortable flying experience. The first Airbus A350-900 ULR for Singapore Airlines was manufactured and assembled at Airbus facilities through a specialized process. This ultra-long-range aircraft featured enhanced fuel capacity, aerodynamic improvements, and Rolls-Royce Trent XWB 84 engines for optimal fuel efficiency. Production took place at Airbus sites like Toulouse or Hamburg, where standard A350 parts fuselage, wings, and systems were built and integrated. Unique ULR-specific components, such as additional fuel tanks and modified systems, were incorporated during assembly. After the main structure was completed, the aircraft underwent extensive testing to meet strict Airbus and Singapore Airlines standards. Its successful delivery marked a major step in expanding the airline's long-haul capabilities and re-established Singapore Airlines as a leader in ultra-long-distance air travel. Technics has completed its first 1B check on an Airbus A350, expanding its maintenance capabilities beyond previous A-check services. Carried out over 2 days in a hangar, the check included functional and operational testing, structural inspection, servicing of aircraft systems, lubrication, and other procedures. Certified for 1B- checks since December 2021, Technics performs this maintenance every 2 years or 12,000 flight hours, whichever comes first. The first Airbus A380 for Asiana Airlines underwent its painting process at Airbus's facility in Hamburg, Germany. This crucial phase marks one of the final steps before delivery and commercial service. Given the aircraft's massive size with a surface area of around 38,000 square feet, the painting operation is an exceptionally complex and labor-intensive task. The process began with preparing the aircraft's surface, which included masking specific areas and applying a base coat to ensure proper adhesion of the final paint. Following this, painters meticulously applied Asiana's signature livery, which showcases the airline's branding and corporate identity. The special livery reflects Asiana's commitment to elegance, innovation, and its Korean heritage. In total, approximately 950 gallons of paint were used to cover the aircraft. Despite the large volume, the paint was applied in very thin layers to avoid adding unnecessary weight that could impact performance. The job required a team of skilled professionals working in a carefully coordinated manner, using a combination of spraying techniques and precision detailing. Once the painting was complete, the aircraft was rolled out of the Airbus paint hangar, revealing its final exterior look. The vibrant colors and sleek finish not only enhance the aircraft's aesthetic appeal, but also signal its readiness for the next stage's final testing and delivery to Asiana Airlines. This painting milestone is a major visual and symbolic step in the aircraft's journey from assembly line to runway, reinforcing Asiana's global presence and brand identity. The Boeing 737 MAX 9 completed its maiden flight on April 13, 2017, marking a major milestone in the aircraft's development. Powered by CFM LEAP-1B engines, the jet flew for 2 hours and 42 minutes, during which test pilots evaluated flight controls, systems, and handling. As a stretched version of the 737 MAX 8, the MAX 9 offers greater passenger capacity and extended range. This first flight followed the successful certification of the MAX 8 and launched a comprehensive testing program ahead of customer deliveries in 2018. The MAX 9 continues Boeing's efforts to enhance fuel efficiency and performance. PLM plays a vital role in managing all product-related information from the initial idea through development to production and post-launch. It connects complex data like requirements, design, and quality, offering an efficient solution to replace scattered spreadsheets and documents. The ANA Boeing 787 Dreamliner is a groundbreaking wide-body aircraft developed by Boeing. Launched in 2004 with All Nippon Airways as the first customer, the 787 offers exceptional fuel efficiency 20% better than similar aircraft, thanks to its lightweight composite structure and advanced engines. The first 787 entered commercial service with ANA on October 26, 2011. Designed for long-haul, point-to-point travel, it carried 200 to 300 passengers with reduced noise and increased comfort. Featuring cutting-edge technology and global collaboration, the Dreamliner represents a major shift in modern aviation. ANA played a key role in introducing this innovative aircraft to the world. The Boeing 787-9 Dreamliner is a technologically advanced, long-range, wide-body twin-engine aircraft developed by Boeing Commercial Airplanes. As the second and larger variant in the 787 Dreamliner family, it offers increased capacity and extended range while maintaining excellent fuel efficiency and enhanced passenger comfort. One of the most notable features of the 787-9 is its lightweight construction. Around 50% of the aircraft's structure by weight is made from advanced composite materials, such as carbon fiber reinforced polymer, which are stronger and lighter than traditional aluminum. This reduction in structural weight, combined with the aircraft's efficient engines, results in up to 25% lower fuel consumption and emissions compared to older aircraft of similar size. EasyJet. Aerodynamically, the 787-9 is designed for superior performance. Its sleek body, smooth wing design with raked wingtips, and optimized lift-to-drag ratio contribute to better fuel economy and extended range. Additionally, the aircraft utilizes electric systems in place of conventional pneumatic systems in several areas, leading to improved efficiency and lower maintenance costs. The 787-9 is also equipped with advanced noise reduction technologies, making it quieter during takeoff and landing. For passengers, the Dreamliner offers a more enjoyable flying experience, featuring larger, dimmable windows, higher cabin humidity, better air filtration, and smoother ride technology to reduce turbulence effects. Sustainability is a key element in the aircraft's design. Boeing incorporates recyclable materials and eco-friendly practices throughout production, ensuring a reduced environmental footprint. The global production of the 787-9 involves suppliers from multiple countries, with major components delivered to Boeing's Everett factory in Washington, where final assembly and system integration take place. HEDA. In summary, the Boeing 787-9 Dreamliner stands out for its innovation, efficiency, and passenger-centric features, making it a preferred choice for airlines around the world. The Boeing 787-8 Dreamliner, a next-generation aircraft known for its composite structure and fuel efficiency, is meticulously assembled at Boeing's facility in Everett, Washington. For Biman Bangladesh Airlines, the assembly process begins with the arrival of major components, such as the fuselage sections, wings, and tail structures, transported from various global suppliers using Boeing's specially modified 747 Dreamliner cargo aircraft. These large structural parts are delivered in a pre-assembled state to reduce assembly time. Inside the final assembly line, technicians use advanced automated tools to join the forward, center, and aft fuselage sections. The wings, built with lightweight composite materials, are then precisely attached to the fuselage. The vertical and horizontal stabilizers are also installed, completing the airframe structure. Following structural assembly, technicians install essential systems including avionics, wiring, hydraulics, air conditioning, and fuel systems. The landing gear and two high-performance Rolls-Royce Trent 1000 engines are then mounted. After that, the aircraft enters the testing phase, where each system is rigorously inspected and validated. Next, the aircraft moves to the paint hangar, where it receives the official Biman Bangladesh Airlines livery featuring national colors and the iconic red-white-green tail design. The painting process is carefully performed in climate-controlled conditions to ensure quality and durability. BAE Systems is upgrading its Samlesbury facility in Lancashire by installing an automated production line to accelerate manufacturing of F-35 fighter jet components. The F-35, considered one of the world's most advanced jets, is part of a massive defense program involving over 3,000 aircraft. BAE has contributed to the program for over 15 years, producing the rear fuselage, fins, and tails. The new assembly line, inspired by automotive manufacturing, uses a monorail system to move parts between stations efficiently. This upgrade will increase output from 1 set per week to 1 per day, securing around 2,000 UK jobs and BAE's long-term role in the project. The S4C inspection is one of the most comprehensive heavy maintenance checks carried out on commercial aircraft approximately every 6 years, or after a specific number of flight hours or cycles. For Titan Airways Boeing 757 registration GZAPX, this intensive inspection was performed by Monarch Aircraft Engineering at their modern maintenance facility. The process began with the aircraft being towed into the hangar and powered down. Engineers started by stripping out large sections of the aircraft's interior. This included removing passenger seats, carpets, overhead storage bins, insulation, and panels to access the fuselage structure and key components for inspection. Externally, access panels and fairings on the fuselage wings and tail were also removed. A core focus of the S4C check is detailed structural inspection for signs of corrosion, metal fatigue, and cracks. Technicians employed advanced non-destructive testing, NDT methods, such as ultrasonic testing, eddy current inspection, and dye penetrant, to thoroughly examine critical areas, including the wing roots, pressure bulkheads, undercarriage bays, and skin joints. All 3 landing gear assemblies were removed and sent for overhaul. The engines underwent borescope inspection and were checked for internal wear and performance reliability. The aircraft's avionics, hydraulic, pneumatic, and electrical systems were carefully tested and repaired as needed. Airworthiness directives and service bulletins from Boeing and aviation authorities were reviewed and incorporated during the check. In parallel with inspection, any required upgrades or refurbishment were completed. This included corrosion removal, component replacement, system modifications, and repainting of structural surfaces. Once all inspection tasks and repairs were completed, the aircraft was reassembled and all systems underwent comprehensive functional testing. Once all tasks were completed, the aircraft was reassembled and subjected to systems testing, including gear swings and flight control checks. A ground engine run and functional checks ensured operational readiness. Ground tests, including gear swings, flight control checks, and engine run-ups, were conducted to confirm full system integrity. After passing all checks, GZAPX was certified as airworthy and returned to service, ready to continue safe commercial operations for years to come. Monarch Aircraft Engineering successfully carried out an Airbus rear Spar service bulletin for EasyJet, focusing on a critical structural component of the aircraft's wing. This bulletin was likely issued in response to potential issues such as corrosion, cracking, or bush rotation affecting the rear spar, an essential load-bearing structure within the wing assembly. The work was performed over the course of a month inside Monarch's maintenance hangar, and it was timed to coincide with a major scheduled maintenance event, likely a 6-year check, to minimize aircraft downtime and operational disruption. Airbus. The service bulletin, issued by Airbus, outlined a detailed procedure for inspecting and possibly modifying or repairing the rear spar area. In many cases, this type of bulletin becomes mandatory once concerns about airworthiness arise. Technicians from Monarch followed a series of complex tasks, including removal of access panels, inspection of the spar and fasteners, cleaning, sealant replacement, and possible rework or reinforcement where needed. If any cracks or corrosion were detected, corrective action was taken according to Airbus guidelines. Throughout the process, strict safety and quality standards were observed to ensure continued structural integrity and compliance with regulatory requirements. The video documentation captured this month-long effort, highlighting the precision and coordination required during such specialized heavy maintenance. The successful accomplishment of the service bulletin ensures that the aircraft remains safe, structurally sound, and airworthy, reinforcing EasyJet's commitment to maintenance excellence and passenger safety. Monarch's expertise played a vital role in this critical engineering task. On November 26, 2013, Monarch Aircraft Engineering opened a 110,000 square feet state-of-the-art maintenance hangar at Birmingham Airport. This multi-million-pound facility supports wide aircraft types, including the Boeing 787, created 150 jobs, and strengthens MAEL's engineering capabilities across the UK. Aircraft structure, surfaces, rigging, and systems assemblers are specialized professionals who build and install parts for airplanes, spacecraft, and missiles. Using tools, machines, and manual skills, they fit, fasten, and assemble critical components, such as airframes and control surfaces. These workers often operate in manufacturing plants where some tasks are automated, but precision manual work remains essential. Their work can involve standing, climbing ladders, or working in confined spaces for extended periods. Safety is a priority, with protective gear and ventilation systems helping reduce risks from chemicals or fumes. While a high school diploma and on-the-job training are usually sufficient to enter the field, advanced positions may require additional education or experience. These assemblers play a crucial role in ensuring the structural integrity and performance of complex aerospace systems, making their work vital to the aviation and defense industries. The tunnel boring machine ASA was specially manufactured to drill through the challenging Hallandsåsen Ridge in Sweden. Built with advanced technology and precision engineering, ASA was designed to withstand high water pressure and complex geological conditions. This massive machine played a crucial role in constructing the Hallandsåsen Tunnel, marking a significant achievement in Swedish infrastructure and tunneling innovation.